We're going to begin by looking at question 5 from the paper that is in front of us. Right, you're able to see my screen, correct?
Yes,
right.
sir.
Okay, thank you. Right, in the diagram, PK, P has coordinates k, and 1 is a point in the second quadrant. Okay, we can see there. And is the square root of 5 units from the origin. Okay, here's the origin, and the distance is clearly exactly the square root of how many units? Of 5 units from the origin. And R is a point on the positive x-axis. Here's the point R there. Okay. And the examiner's asking us a good question, and a very simple one, to calculate the value of k. So we just need to find the value of k. How do you find the value of k? K is a coordinate, so it's very, very easy to find the value of k. Every time we see a diagram like this, we need to always make a right-angled triangle. And remember, the first component is x and the second one is always y. So that at this point, you're able to see that if that is true, our y there is 1, and we can see therefore that our x equals what? Equals k. At this rate, we're able to observe therefore that actually the square on x plus y squared is a square on r, and this is called Pythagoras theorem of Pythag. We do substitution, right? So our x is k, we put it in, our y is 1, we put it in, equals r squared, which means k squared is r squared minus 1, which means k squared is r squared minus 1. And then now, at this point, we want to solve for k. So what we do is we observe something here. Okay, we observe something here. We apply the square root on the left, the square root on the right. And then we put a plus or minus. Okay, so the square root has 2 solutions all the time. So it is therefore that, okay, we have the r, so we can plug it in. So if we wish, we can do it like this. We can do it like this. So we can just say, do substitution, substitute both. So we substitute the x, which is k squared, and then the y is 1, and then the r is the square root of 5. Okay, yes, please. You agree, right?
Yes,
okay,
I was just
so
confused by the 5.
Oh, okay. Right, so the square root of 5 is actually 5 there. So which means k squared is 5 minus 1. What is 5 minus 1? It's actually 4. You take the square root both sides, the square root of k squared, and then you have the square root of 4, and then you put plus or minus, which means k is plus or minus what? Plus or minus 2. Okay, but we need to choose one of them. But you can see therefore that on this side here, x is what? Is negative, so k can only be the negative 2. Okay, so that is exactly what we observe there. All right, and then we continue to do the questions, and we answer the next question. The next question is as follows. Right, without using a calculator, calculate the value of the tangent of theta. So the tangent of theta, this one we use something called SOHCAHTOA. And SOHCAHTOA would actually mean to us that the tangent is the opposite over the adjacent. So theta is this angle here. So the opposite is the y, which is exactly 1. And then over the adjacent is the x value, and which is minus 2 there. Okay, so you have minus 2 that sits here, you have y that sits there, and that, so this becomes most definitely the answer, in which case it becomes exactly minus 1/2. All right, to get this one here, which is 180 degrees plus theta, it can be done in many ways, but the easiest way is to first reduce this. In each quadrant is 180 plus. 180 plus is in each quadrant. So 180 plus is in the third quadrant, and the cosine is negative in the third quadrant. And this becomes cosine theta. Right. So what is the cosine here? According to this, is the adjacent over the hypotenuse. Looking at the diagram, there adjacent, there is what is -2, and over the hypotenuse is the square root of 5, and this is exactly 2 over the square root of 5 units there. The next thing we need to just determine is actually letter C, and letter C is just very, very similar. And now we start with that one, and then we then say, what is the answer to this? Okay, what is our approximate starting time now? I need to record that so that I cannot forget, because obviously we started a little bit after time. Right, so I'm
we
seeing that.
started at 9:10.
Oh, is that at 9:10? Okay, thank you so much. We started at 9:10 p.m. Okay, yeah, so that I cannot forget. Thank you. Right, so we need to now, without using a calculator, calculate the value of this one, write it in the form that. Okay, so, right, so we continue with answering these past exam questions. They are very solid food for us. Okay, now to do this one, it's a bit lengthy, so we're gonna proceed a little bit at the bottom there. So we're looking at C. Okay, we're looking at C there. And that one is actually, so to do that one, we let the left-hand side be the sine of theta plus what? Plus 60 degrees. And what is this? The sine of these, we use the compound angle formula. So the sine of these becomes the sine of theta, the cosine 60 plus cosine theta, the sine of 60. And then what is sine theta? Right, so sine theta, we go to the diagram and we take it from there. Here's the diagram. And the sine of theta would be, theta is this angle there, would be the opposite over the hypotenuse, which is 1 over the square root of 5. So this one becomes exactly 1 over the square root of 5. The special angles are to be remembered, because you know that if this is this one here, and this is 60 degrees, this is 30 degrees, and this is 2, this is the square root of 3, this is 1. So if you have the cosine of 60 degrees, becomes the adjacent of the hypotenuse. So this is the adjacent, this is the hypotenuse. So it becomes exactly 1/2. We look for the cosine of theta from the diagram, and the cosine of theta, according to these, is actually the adjacent of the hypotenuse. So if you look at the angle theta, the adjacent is actually -2. The hypotenuse is the square root of 5. So you'd have the adjacent, which is -2, over the hypotenuse, which is obviously the square root of 5 there. And then we continue and we do a little bit more. Right, the sine of 60 from the using SOHCAHTOA as well, we're able to get that one. So the sine of 60 degrees is actually the opposite 60, which is the square root of 3 over the hypotenuse, which is exactly 2 there. Okay, good. So we found that from this friend. This diagram is called the special triangle, in which case it contains things we call it contains spatial angles. Okay. In which case, we continue with the multiplication. So 1 times 1, the numerator is 1. In the denominator, we have the square root of 5 times 2, which is 2 to the square root of 5, minus, so at this point, we have that these 2 cancels, and we have minus the square root of 3 divided by the square root of 5. And then now we have the square root of 5 here. You have the square root of 5 divided by 2 to the square root of 5, which is actually a 2 there. Right, in particular, my point is we have the square root of 5 divided by 2 to the square root of 5. And the result is, in particular, you need to have that as part of your denominator. Okay, all right. You need to just have that, so that if you divide here 2 to the square root of 5 by 2 to the square root of 5, you get 1 by 1 is 1. 2 to the square root of 5 divided by the square root of 5 is 2 times that, which is 2, the square root of 3. And therefore, this becomes the sine of theta plus 60 degrees. Okay, so at this point, we're able to continue and say this is what we get. All right, so the denominator, according to the examiner, must have the square root of 20 in it, and an a and a b. So which means therefore this is theta plus 60 degrees. So there must be a square root of 20 in the bottom. So we can get the square root of 20 out of this because 4 is the square root of 2, excuse me, or the square root of 4 is 2. So you can just put square root so that you can multiply 4 and 5, because 4 by 5 will give us 20. So in the denominator, therefore, this becomes 4 by 5, and then 1 minus the square root of 3 to the square root of 3, the sine of theta plus 60 degrees. And then this becomes the sine of theta plus 60 degrees, which is 1 minus 2 the square root of 3 divided by the square root of 20. So that becomes the answer. So this becomes the sine of this is of theta plus 60 is 1 minus 2 the square root of 3 out of 20. Okay, so that is exactly the answer there. All right, so we continue and we solve more problems. Okay, this video is being recorded, so you'll have access to this. So in other words, if we come to this question, we ask what the answer is to this one. So this is actually 1 minus 2 the square root of 3 is we found it at the bottom, all divided by the square root of what? Of 20. Now to look at 5.1.3, right, use a calculator to calculate the value of this one, correct to 1 decimal place. And this time around, you need to use a calculator to answer this question, and we use a calculator to answer this one. Okay, so we continue as follows. Right, so to calculate the value of these to correct to 1 decimal place. Okay, let's look at that. So, and the fact that we need to calculate the value of this one, 5.1.3. So I'm going to clean the board a little bit up so that we can continue. I'm going to clean it up so that we can continue. Cleaning, 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 cleaning. So that we can continue. At this point, we are answering the question 5.1.3, and we want to get the value of the tangent of 2 theta minus 40 degrees. But the tan of theta, we got it from the question above, is minus 1/2. Now what we do at this point, to get the value of theta, we first find something called the reference angle, and the reference angle becomes arctangent of the positive. So we take the positive angle, and if we do, what is the answer to this? So the answer to this is arctan 1/2 is 26.57 degrees if you use a calculator. Okay, that is the reference angle. And then now we ask ourselves a couple of questions about where the tangent actually becomes negative. So we look at the cast diagram and realize the tangent is negative here and it's negative there. Okay, it's negative in the 2 quadrants. Right, so if it's negative in the 2 quadrants, it means actually our theta will be, if we are to be here, is going to be 180 degrees minus 26.57 degrees, which means theta is 180 minus 26.57 is 153.43 degrees. Right, so once we have these, then we're able to continue after dividing the whiteboard here. And we're able to see, therefore, that if we have the tangent of 2 theta minus 40 degrees, which is the same as the tangent of 2 into theta, which is 153,43 degrees minus 40 degrees. And then what is the answer to this? It is exactly the tangent of, okay, if you multiply these 2 and that, it is 266,87 degrees. And then if you take the answer, the tangent of that is 18,3 there. And then this obviously becomes the answer. So the tangent of that is 18,3 there. Not in degrees, obviously, but now if this obviously is the answer, let's check what the instruction was to 1 decimal place. So indeed, the answer has been obtained exactly to 1 decimal place, 0.3, and therefore it is 18,3, 1 decimal place, and to something called a three significant figures. Okay, I'm going to discuss significant figures at some point very briefly and how they work in math and science. Okay, we're done with this one, and then move to the next question. The next one obviously is 5.2, and that is very straightforward. Let's just get started with it. Right, so to do that one, we are gonna be very excited to solve it. How do we solve that one? Okay, we solve it with so much ease and energy and zest. We solve it with so much zest and energy. In 5.2, first things first, we're gonna prove this identity, but to prove identities, we always choose the most complicated side and simplify it. So now we're gonna choose the left. So we're gonna take the left-hand side. So the left-hand side is the same as cosine theta plus sine x, excuse me. Okay, it's not theta here. It is cosine x plus sine x. It is divided by cosine x minus sine x minus cosine x minus sine x, all divided by cosine x plus sine x. That is the left. So just remove this red one. Okay, so we're going to we need to somehow add these two guys. And to add these two guys, we do the following. So it becomes cosine x minus sine x into cosine x plus sine x. To divide this denominator, I've just picked this one of each of these denominators and I multiply them to constitute something we call the lowest common denominator, okay, of the two fractions. So this divided by the cosine x minus 1, we actually get cosine x plus sine x. We multiply by that, so it becomes cosine x plus sine x, but it becomes squared because it's the same thing. If you divide this one by the cosine plus sine, it becomes cosine minus, you multiply, is cosine minus sine. Continuing, we just do expansions. So if we were to square this one, cosine, if you square it, becomes cosine squared x. Cosine times sine times 2, it becomes 2 cosine x sine x. You square the sine, it becomes sine squared x minus, if you square the cosine, it becomes cosine squared x. Cosine times minus sine is minus cosine. Sine times 2 is minus 2 cosine x sine x. You square the sine, it becomes sine squared. All divided by the denominator. And the denominator is like that. Okay, so we focus on the denominator, and denominator can be seen. So the denominator becomes a difference of two squares because they just differ by a sign here. Okay, if they differ by a sign there, we have a difference of 2 squares. Cosine times cosine becomes cosine squared x, and then cosine times sine becomes cosine x. Sine x, sine times cosine becomes minus sine x, cosine x, and then the sine times sine becomes minus sine squared x. So we have the left-hand side, which is the same as. Okay, we continue with the simplification here and see what we get. Dealing with expanding everything there, we're able to see that the top is cosine squared x plus 2 cosine x sine x plus the sine squared x minus cosine squared x plus 2 cosine x sine x, and then we subtract the sine squared x. It is all divided by the denominator. Okay, the denominator. By the denominator, you can see that these two guys cancel out, leaving us with cosine squared x minus sine squared x. Cosine squared cancels out, sine squared, they cancel out, and we have the left-hand side, which is 2 cosine x sine x plus 2 cosine x sine x, which is 4 cosine x sine x divided by the following. So it is actually divided by cosine squared x minus sine squared x. Okay, so, and what is all this? So this is actually the same as 4 is the same as 2 times 2, and then we have cosine x sine x, and this is divided by cosine squared x minus sine squared x is a double angle trigonometric formula for cosine 2x. 2 into 2 sine x cosine x is sine 2x divided by cosine 2x. What is sine over cosine? It is tan 2x. And this is actually equal to the right-hand side. This is actually equal to the right-hand side. So we have dealt with this question. We're able to see that it works out to 2 the tangent of 2x. 2 the tangent of 2x equals the right-hand side there. Okay, this video, this lesson is being recorded, and therefore access to this lesson is most certainly guaranteed. And then you'll have a chance to pass through this lesson and make sure that you understand this. As a way to do that, it's very important that you you write down the questions and the answers during your own leisure, so that you're able to understand the things. I don't want to crack your skull. It's very important that you are at par with these kinds of things. Okay, we continue. We do more mathematics today, more mathematics, and then we shall see how well we do. All right, so we actually have the following there. Right, so the next one is 5.3. So we look at the answer to 5.3. 5.3, we start with 52 degrees. A equals 38 degrees. Cosine squared of A. And this becomes cosine squared of, so we have 38 to 52, so we just calculate the summation of this. So this is the sum, and this symbol is called sigma, and this is denotes the sum the result after addition is called the sum. From 38 degrees to 52 degrees, so we shall say 38 degrees here plus cosine squared of 39 degrees plus cosine squared of 40 degrees plus cosine squared of 41 degrees plus cosine squared plus cosine squared of 42 degrees. Okay. Right, we shall have lots of them, so let me just jump some of them. Okay, 41, let me just say it 40, and then we shall say dot, 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 and then we shall have cosine squared of 51 degrees plus cosine squared of 52 degrees. Okay, so let's see what we get out of this. Right, so what is all these actually? What is all this kind of stuff? What does this mean there? What does this mean? So we look at the simplification of these and see what we can get, because this one, the cosine 38 is the same as cosine 38. These things are equal to, so you know that in mathematics, the cosine of theta is always the same as the sine of 90 degrees minus theta. In each quadrant, 90 minus. In each quadrant is it? Is in the first, right, where everything is positive. So which means that this is what we can do. So we can work this out and say, at this point, 90 minus 38. What is 90 degrees minus 38 degrees? 90 minus 30 is 60, and then 60 minus 8 would be what? Would be 2. So it would, therefore, but it's just that the function changes from cosine to sine when you do that. So this is going to change to sine. And then this is going to change to what? To sine. 90 minus 39 is 51 degrees. And this cosine is going to change to sine. 90 minus 40 is 50. And then this is, this one you can keep. You can keep these ones here at the cosines as they are. So that you have cosine squared 51. Plus cosine squared 52. And then now if you have sine squared plus, okay, so you can sort of pair these things up. You can pair them up like as follows. How do you pair them up? So you're gonna add these up. Like if you check very carefully, you'll see that if you have the sine squared and 52 and the cosine squared of 52, they give you 1. The sine squared of 51 plus cosine squared 51 would give you 1, and so on. But in other words, counting from 38 to 52, you will have 7 of these ones, plus a special angle that is going to occur between these. Okay, so obviously you realize that we moved from the 38 to 52 and went through 45 degrees, which is, and this 45 degrees is a special angle. So we're going to have in the middle, cosine squared of 45 degrees. Cosine of 35 is the square root of 2 over 2. If you square this one, it becomes 2 over 4. Plus, so this is 1/2, which is 7 and 1/2. That's the answer, 7 and 1/2. So in other words, we're to calculate the value of this one without using a calculator, and the value is actually 7 and 1/2 there. Okay, I continue and do more math because we've done the whole of this full question, and then we do the next one, question 6. This one is based on geometric graphs, and we answer question 6 there. Right, consider, for instance, at this point, the function, the tangent of x, f of x equals minus 2, the tangent of 3 over 2x. Write down the period of f. Right, so the period at this point is given by always given by 180 degrees for the tangent, but you divide it by this. So you divide by 3 out of 2, which means it is gonna be 180 degrees. You multiply by 2 over 3. And then you simplify these. 3 goes times into 180, it goes 60 degrees times. And therefore you multiply that by 2, and the result is 120 degrees. What is the period? So the period is exactly 120 degrees there. Okay. We continue to the next question. All right, 6.2, the point. A has coordinates t and 2 lies on the graph. Determine the general solution of t. The point, this one, lies on the graph. Determine the general solution of t. Okay, 6.2. Right, so if you look at the fact that this point lies on the graph, you need to determine the general solution of t. So let's look at this one. So first and foremost, we look at what the graph is. So here's the graph, it's f of x equals that. So right, so you have the graph is actually f of x, which is minus 2, the tangent of 3 over 2x. The point A has coordinates t and 2. In which case, therefore, it is x and y. So what is y? Y is 2 equals minus 2. The tangent of 3 over 2x is t. Right, so at this point, you divide both sides by 2, and then you can divide by minus 2 so that we have minus 1 equals the tangent of 3 over 2x. Okay, what is this? This is good news because we're getting to this point, and at this point we have a very interesting observation. But first we need to get the reference angle. So it's something called the reference angle. The reference angle at this point is obtained by saying arctan of the angle 1, or rather the 1, you take positive 1, and then that one is going to give you 45 degrees. But where is the tangent by the cast rule? Where is the tangent negative? It is negative in the second and the fourth quadrant. So they're basically a host of 2 solutions. So now the first solution is obtained in the second quadrant. So that solution is going to occur when we have 3 over 2 t, which is 180 degrees minus 45 degrees, plus k times 180 degrees, the period of the tangent function. So 180 degrees. So you have 3 over 2t. What is 180 minus 45? Is 135. So you'd have 135 degrees plus k into 180 degrees, and k is an element of the set of integers. So which means t is actually 2 into 135 degrees divided by 3 plus k into 180 degrees, 2 over 3. So you multiply this. 2 times 135 is actually 270 divided by 3 is 90, and then by this one here is 180 divided by 3, 60 by 2 is 120. So this will give us 120 degrees. So it's k times 120 degrees times k. Okay, I have k already. I have k. It's in the integers. All right. Or we have 3 over 2. Okay, the next one now is also in the fourth quadrant here. And now we can determine the general solution, so we can be able to get the answer there. So right, in the fourth quadrant, you can take minus 45 degrees, for example, because it's here minus 45 degrees. So you can say minus 45 degrees, and then the period of the tangent function is k times 180 degrees. K is in the integers, so which is 3 over 2. All right, so I can remove this one. Right, so t equals, so well, you multiply by 2. So 245, you divide by 3. K for 180, the 2 is at the bottom, so you multiply by 2, you divide by 3. So 2 times 45 is minus 90, divided by 3 is minus 30. And then divide 180 by 3, you get 60. By 2, 120. So this is k times 120 degrees. K sits in the integers. So that's what we get at these points. At this point. So we have the minus 30, and also you have the 90. Plus, so these are actually the actual general solutions, or they constitute what we call the general solution to the trigonometric equation there. Okay, good. We will have access to all this. And then now, obviously, we said the point lies on the graph to determine the general solution. Of the 3 marks, we've just gone above and beyond there. All right, so we're good anyway. The next question says, on the grid provided in the answer book, draw the graph of f for the interval minus 120 to 180. Clearly show all the asymptotes and intercepts with axis and endpoints of the graph. Okay, we need to just draw that graph there. Right, so very, very straightforward. So we just get it drawn quickly. Get it drawn quickly. Right. We get it drawn really quickly. Okay. Now to draw that graph in 6.3. Okay, so we're looking at 6.3 now. Okay, so to do that graph, let me draw a big one to make sure it's very visible. Right, so it is the graph of the function f of x equals minus 2 the tangent of 3 over 2x. Y and x. Right, so now the couple of things that are very important for this graph. You need to determine the actual appropriate graphing step of this function. Right, so we need to find the graphing step of this function. So to find the graphing step of this function, you need to think very, very carefully, because the graphing step of the graphing step of the original tangent function y equals 10x. The step is 45 degrees. Right. So now that's one thing you need to realize, and therefore generally the step would be calculated as the period. You divide the period by 4 into the coefficient of the x there. Okay. So at this point, if you look at this, they say the step is 180 degrees, is 4 into the coefficient, which is 3 over 2. The step is going to become what? So it's going to be 180 degrees. You divide it by 4, but you multiply by 2 over 3. If you divide 180 by 4, you get what? You get 45. You get 45 degrees. You multiply that by 2, get us 45 degrees. Okay, so you multiply by 2, but you divide by 3. So this is 90 divided by 3, which is 30 degrees. So we're going to be moving in steps of 30. It's very important that you calculate this step. So this is going to be exactly 30. 30 plus 30 is 60. 90. Okay, so it must be up to 180 degrees there. So this one is 30, 120, 150, 180. Minus 30, minus 60, minus 90, minus 120, minus 150. Hey, I've gone beyond. I must stop at minus 120. So I'm going to just stop here. Okay. This is the graph. And then we just complete the graph between minus 120 and 180 degrees. Right. So we need to use a calculator to do this one normally. Right. So, but there's a couple of things that are very important here. So you need to draw a table normally, and now you can use your calculator to draw the actual table. So we've seen that I need to note that one now. The step is 180 degrees divided by 4 into 3 over 2, which is 30 degrees. Now we do this. We need just a table. If we're to be organized, X and then Y. So we have minus 120, we have minus 90, we have minus 60, we have minus 30, we have 0 degrees here, we have 30, we have 60, we have 90, we have 120, 150, and 180. Right, if you take the tangent here of z0, it's going to be 0. Right, so at 60, at 30, here you're going to divide 30 by 2 and get 15. By 3, you're going to get 45. The tangent is 1, but there's a negative, so we have that, a negative 2 there. Okay, so this one is they're just gonna differ by sign. Okay, if you put 60, you put 60 by 3 is 180 divided by 2 is 90. The tangent becomes UND, undefined. At 90 degrees, you divide 90 by 2, it becomes 45. By 3, it becomes 135. Right, so yes, it becomes 135, and the tangent of 135 is actually in the third quadrant rather than the second quadrant, and the tangent is negative there, but it's a negative, so it becomes plus there. All right, but now here the side it's going to become undefined as well, and so now this is going to become that. So now this one here. Okay, 0 at 30 degrees, it's going to be negative 2. Okay, so at minus 30 is going to be 2. So you have these. Right, so you continue and graph this, okay, like we're doing. Okay, it's going to have asymptotes there, but also there's going to be another asymptote. Let me see. Where else the asymptote is going to be? Right, it's also going to cut at 120. So it's going to do this. So there's going to be again asymptotic at 180, because at 180, you take 180, you divide it by 2, you get 90 by 3. So this becomes like 270. So the tangent becomes undefined there, and also becomes, okay, so it's not, because it's outside that. Right, so, but you note that at 180, at 120, you divide 120 by 2, it becomes 60 by 3, it's 180. Right. So this is what the graph you're going to have. Let me see what other pieces of the graph are going to be there. Okay, we're revising graphs and functions a little bit. So it's going to be at 120 as well. And it's going to be like this. So you know the graph is going like that. It's going like this, and it's going like that. And so we have this. Okay. Now let's continue and analyze this. So we've just sort of drawn the graph there. Right. So there are many important points that are very important points here. For example, the asymptote is occurring at x equal to 60. The equation of the asymptote, this is x equals 180, but it's also x equals minus 60 degrees. And then okay, let me see what else. So the the x-intercepts, they're okay at 0, 0 there. So let me write down here. Okay, there are certain things we call the x-intercepts. The x-intercepts, they're okay at 0 degrees, but they're also okay at plus or minus 120 degrees. Their asymptotes, so the asymptotes are k at plus or minus 60 and x equals 180. They're okay at minus 60 and also at 60. And then now there is also the negative shape. This shape is the negative shape of the tangent function. It's called the negative shape. Negative shape. Now at 90 degrees and 2, so you have 90 degrees and 2 minus 30 degrees and 2, 30 degrees and minus 2, minus 90 degrees and minus 2. Okay, like 90 degrees and 2, you actually are able to see that those are very, very important points. At 90 degrees and 2, those are points where the function sort of at 90 degrees and 2, we have a salient point, a very important point where the function sort of changes its concavity there. All right, so those kinds of things. And you have those points there. Okay, right. I want us to look at another question, please. Let me see. Okay, right. I want us to look at another question. For example, we had to show all the asymptotes, the intercepts, the axis, and endpoints of the graph. What are the endpoints of the graph? Like this endpoint is a point. So we have minus 120 degrees and 0. And this endpoint of the graph, for example, is 180 degrees and 0. Okay, we continue there. So now use the graph to determine for which values of x will f of x be greater or equal to 2 for x between minus 120 and 180 degrees. Use the graph to determine for which values of x will the function f be greater or equal to 2, right? So now to answer that question, we look at the following, right? So y equals 2, so you have that y equals 2 there. Okay, so you have y equals 2 there. Right, so it's not accurate, but yeah, y equals 2, you have something like this. Now, for which values of x will that be? So we're looking at parts where the function is above. So there it's above, but here it is below. Here it is above, but here it is below. Okay, right, so for what values of x is that the case? And we together analyze that, which means it is that x for instance, x minus 60 degrees. And then for x, now here it's going to be 60 degrees, between 60 degrees and 90 degrees. Right, so these are the two intervals. So when x is an element of the interval from 60 degrees to 180 degrees to minus 30 degrees here, you can see that the function is above. From 60 degrees to 90 degrees, still. Okay, you don't write it like this. You can say minus 60 degrees, minus 30. 60 degrees, 90. Describe the transformation of graph F to form the graph of this one. Okay, so what kind of a transformation has happened? If we look at the fact that the function F was minus 2, the tan of 3 over 2x, but now it has become this. What on earth happened? Okay, so a couple of things have happened here. Now, this is what actually happened. So there was a transformation of the function according to this rule. So this happened. So there was the function f. The function f of x was minus 2, the tangent of 3 over 2. So, but you have f of x plus 40, which is minus 2, the tan of 3 over 2 into x plus 40, which is x plus 40. So that's sort of what happened. So you have the x plus 40, because that's what you're going to sort of get. If you multiply it through, it's going to become 3 over 2x, and then you divide 40 by 2, it becomes 20, by 3, it becomes plus 60. So that's what happened. So it was translation. Translation of 40 degrees to the left. Okay, because it was the 40 degrees was added, so it was a translation of 40 degrees to the left. So that's what happened. So it was just x plus 40. Okay. Right. We are going on. See, so that's what we get from the graph question. Obviously, this lesson is being recorded, so we'll have an opportunity to enjoy that. Okay, I want us to spend a little bit of time looking at this 3D trigonometry, three-dimensional trigonometry. So this pertains what we call three-dimensional trigonometry. A pilot is flying in a helicopter at point A, which is 8 meters directly above point D. On the ground, he notices a strange object at point B. Okay. The pilot determines that the angle of depression from A to B is 30 degrees. Here's the angle of depression from A to B is 30 degrees. He also determines that the control room at point C is 3h meters from point A. This one, 3h meters from point A. And BAC is 2x. Here it is, 2x. Points B, C, and D are in the same horizontal plane. B, C, and D are in the same horizontal plane. This scenario is shown in the diagram. Okay, we can see everything the question describes. And then, what are the questions? Determine the distance AB in terms of h. Determine the distance AB in terms of h. So if this is A and that is B, we need the distance in terms of h. How can we find this distance in terms of h? So now we are in business. We are in business, so it's just let's get cracking. Let's get started. Right, to get started, we note that the angle ABD is 30 degrees. First, because this is parallel to this and they are alternate angles. So to find this distance, then you're going to say in triangle, right, in triangle. Yes, please.
So my laptop is on 14% and I don't have a charger here. So if it cuts,
okay.
it's not that I ended, it's just because my laptop is off.
Oh, okay, I understand. Okay, that's fine. This is the
Okay.
very last question we're going to do. Okay.
No problem, sir.
Okay, thanks. Yeah, thanks for letting me know because
Yes.
I would feel very energetic to continue. Right. So in triangle ABD, so you're going to have opposite over hypotenuse. So you're going to have the sine of 30 degrees. Opposite, which is AD, the hypotenuse is AR. So AD, but AR. AD is the same as H. So we want to get AB, so we cross multiply, so AB goes there and the sign sits at the bottom. So which means AB is H over that meters. Okay, so that is the answer. So the answer is that one. So AB in terms of H, so it is exactly that one. All right. But now obviously you know that sine 30 is 1/2, which means that this is H multiplied by 2/1, which is 2H. So what is AB? AB is double H meters. Okay, it's double H meters. So that is exactly AB there. Now, the last question is show that the distance between the strange object at point B and the control room at point C is given by this. The strange object at point B and the control room C is that one there, right? So it is this one very straightforward, but note therefore that you have this triangle, this angle here is ABC. So you have ABC, and this one is 2x. So what are we getting here? So we have 7.2, and then we have BC. You have BC squared, which is we have 3h, and then we have AB, which is 2h. So which means that BC squared in this BC squared is AB squared plus AC squared minus 2AB AC cosine of what? Cosine of the angle BAC. Okay, this is called the law of cosines. Or sometimes it's called the cosine rule. Okay, so we continue with this. And then now you have AB, which is the same as 2H. You square this one, and AC is 3H. You square these 2 into AB, which is 2H. The AC is 3H. Cosine of twice X, BC squared. You square these, it becomes 4H squared plus 9H squared minus 2 by 3, 6 by that, it's 12H squared. All right, so this is BC squared. 4 pi plus 9 is 13H squared minus 12H squared. What is cosine 2x? The double angle formula, which is cosine squared minus 1. Okay, I'm very aware that your laptop is running on low battery, so I'm rounding up my discussion. So if you multiply through here, this is going to be 24 h squared cosine squared x minus, okay, minus is going to be plus 12 h squared. And then you add 13 and 12 h squared. It is the same as what? It is 25 h squared minus 24 h squared cosine squared x, which is BC squared. Which is 25 h squared minus 24 h squared cosine squared x. Then you put the square root like this, you put the square root like this, which means, which is 25 h squared minus 24 h squared cosine squared x. And then now you pull out h squared, which means 25 minus 24 cosine squared x. Okay, take the square root of h squared, which is h, and then this is 25 minus 24 cosine squared x. Okay. So that is the answer. So in other words, BC is this one. BC is exactly this. H into the square root there. Okay, of 25 minus 24 cosine squared. And therefore that is the answer. I must thank you so much for joining us. Okay, this lesson is being recorded. I'll post it again on YouTube, so you'll have access to it. I'll send you the link afterwards. Thanks a lot for joining us and have a good evening. Okay.
Thank you, sir. Bye, sir.
Okay, thanks. Karabo. Goodbye.